Question 4. Once again, it looks like there's a lot of writing here, a lot of bits to read, but actually all of that is just the information shown on this graph here. And we're being asked to find out where's the turning point. Well, there's the turning point there. It was at 4 minus 1.5. But we're being asked to find out what would happen if we times it all by 2. So what we're saying is it's going to stretch times by 2 in the y direction. Look, all the y values are getting 2 times bigger. And so this means that this point is now going to be at 4 minus 3. It's still 4, it's not going in the x direction, it's just this bit here is being times by 2. Now, we've got the same sort of idea here. What's going to happen here? This graph has moved one place to the left. Everything has moved one place to the left. And so these roots here would have moved across to here. They'd be at 1 and 6. You've been asked what the largest root is, so the largest root is x equals 6. State the range for which g dashed of x is less than 0. Well, in question 1, we asked when the gradient was positive. We asked when is it going up. This says when is the gradient negative, which basically just means when is it going down. And you can see it's going down all this time here, all the way down to there. So it's going down when x is less than 4. One extra bit here. Look, there's a or equal to there. So I'll add an or equal to there as well. And the last bit, I'll change colour because my graph's getting a mess. What it's going to say here is, we're saying we're going to add k to it. We're going to add k to it so it's got no real roots. Well, adding k to this thing is going to move the graph up. And if I'm going to move the graph up so it's got no real roots, that means it's not going to touch the axis at all. So it's going to be up here, not touching the axis here. Well, just to move it up to that point there would be I'd need to add 1.5 to it. So if I put more than 1.5, then this graph would be above the axis and it would have no real roots.